Hey, what's going on, guys? Let's see how we can find the volume of the region bounded by these two equations. Y is equal to x cube and x is equal to 1, right? So let's draw the diagram graph for this one. So first we have to draw y is equal to x cube graph. That's going to look something like this, right? And this is our y is equal to x cube graph, and this is going toward x is equal to 1. So x is equal to 1 is going to be a line. So this is the region we are interested in. This is the volume of the region. This is the volume we have to find. Let's see how we can calculate this. And also they have given that it's rotating around y is equal to 1. So this is 1, and we have to know the limits of integration. Maybe this 1 is our limits of integration. Let's check it. So to find the limits of integration, all we have to do is equate both of them. So first of all, I have to rearrange this one. Since this is rotating around parallel to x-axis, we have to write everything in terms of y. So this is going to be dy. So let's change this one in terms of y first. So to do that, what I have to do is just cube root power by 1 by 3 both sides. So this is going to be x cube power 1 by 3 and y power 1 by 3. So x is going to be equal to y power 1 by 3. Now if we equate both of these equations, x is equal to 1 and y is equal to 1 by 3, that's going to give us the limits of integration. So here we are going to have, so we know that it's starting from 0. The other one is going to be just 1, because if you cube root 1, that's still going to be 1, right? And that's positive 1. So this is positive 1. So this is going to be our limits of integration too. So now let's see how we can find the radius and height. That's the main thing. Let's put the equation first. V is equal to 2 phi integral, since it's rotating parallel to x-axis, we have to write everything in terms of y. So here we are going to have BC, integration going from B to C, height times radius. So radius is going to be in terms of y, height is also going to be in terms of y. So that's the main thing. So let's see how we can find the radius right here. To find the radius, the technique we can use is, whenever this is rotating parallel to x-axis, we draw a rectangle parallel to x-axis. In this case, the height is going to be the radius. If it's parallel to y-axis, we take the area radius in the x-axis. But if it's rotating parallel to x-axis, the radius is going to be in the y-axis, right? And the radius will be the distance from the rotating region and the rectangle we are drawing. So this is going to be our r. And the height from origin, wherever the 0 is, from this one to the rectangle we are drawing, that's going to be y, right? And we know this total region is 1. Total distance for this one is 1. And from this one, we have to find the radius in terms of y. That's the main thing. So r is equal to, we know this total is 1. If we subtract this y from this one, that's going to give us this distance. That's going to be radius. So we can write r is equal to 1 minus y. So now we have found the radius, and let's see how we can find the height. Height is going to be outer region minus inner region, right? That's the equation we use. I mean, that's the definition for height. But here, what is the height? If it's parallel to y-axis, then we use outer, the top function minus bottom function. If it's parallel to x-axis, we have to use this one right here, right top function and right bottom function, right? So if we draw a arrow through this region, wherever the arrow touches last, that's going to be the outer region. And if you draw an arrow and wherever the arrow touches first, that's going to be the inner region. So if you draw an arrow through this is the line that's going to touch last. That is x is equal to 1, so 1 is going to be the outer region. And if we draw an arrow that touches this one first, that's going to be the inner region, but we want this one in terms of y. We know this equation of this one is equal to y is equal to x cubed, but we want this one in terms of y, and we already converted it. X is equal to y power 1 over 3. That's the one we are going to put right here. So this is going to be h is going to be 1 minus y power 1 over 3. Now we have the height and radius. This is the hardest part in this problem. If you can figure this one out, rest of them are easy. All we have to do is plug it in this equation. Let's go ahead and plug this. So this is going to be v is equal to 2 phi integration going from the limits of integration we already know it's going from 0 to 1. Here the y is going to be the limits. If it's rotating parallel to x-axis or in the x-axis, y is going to be the limits of integration. So here this is going from 0 to 1. So 0 to 1 is going to be the integration. And then let's plug the radius and height. Radius is 1 minus y and height is 1 minus y power 1 over 3 dy, right? Let's multiply this one. 2 phi going from 0 to 1. 1 times 1 is going to be just 1. And then 1 times minus y power 1 over 3 is going to be minus 1 y power 1 over 3. And then minus y power times 1 is going to be just minus y. And then minus y times minus y 1 over 3 is same as adding 3 by 3 plus 1 by 3, like 1 by 3 plus 3 by 3. So this is going to be 4 by 3 plus 4 by 3. Right, now we have multiplied and simplified this one. Let's see whether we can add them together, right? If we can add them, that makes everything easier. 2 phi 0 1, and this is, if I write this one in terms of 3 by 3, 1 is same as 3 by 3. 3 by 3 is 1, right? So I can write this one as 3 by 3. So that's going to give us 1 minus 1 over 3. We just have to add these two. So that's going to be 4 by 3. Y power 4 by 3. And this is plus, oh wait a minute. We can't do that because this is not multiplication. This is addition, right? So we can't do that. Let's keep it as it is. 1 over 3 minus y plus y power 4 over 3. Let's do the integration. If we do the integration, this is going to be 2 phi y minus, if I integrate this one, this is going to be 1 over 3 plus 1. So that is equal to 3 by 3 plus 4 over 3. So this is going to be y power 4 over 3 divided by 4 over 3. Instead of putting 4 over 3, I can put 3 by 4, because 4 over 3, the bottom 3 is going to go to the top, so it's still going to give us the same answer. So we can put the 3 on top, 4 in the bottom, and then we have y, so this is going to be just y square divided by 2. Then this is, if we add 1 to this one, this is going to give us y power 7 over 3. 7 over 3 divided by 7 over 3, I can bring the 3 to the top, so that's going to be multiplied by 3 divided by 7. So this is going to be the integration of this one, and this is going from 0 to 1, right? 0 to 1. Let's simplify this one. Since it's 1, it makes everything easier, otherwise it's going to be really hard, right? So let's substitute the 1 right here. 1 minus 1 times 3 is going to 1 to the any power is going to be 1. So any power y has is just going to be 1. So 1 times 3 is going to be just 3. 3 by 4 minus y square over 2 is just 1 over 2 plus y 7 by 3 that's just 1 times 3. 3 by 7. Let's simplify this one. So here we had to take the common denominator. Let's continue this one right here. So common denominator, we have to get a number that's multiplied by 4 and 7 both. So we can simply multiply 4 and 7. That's going to give us 28. If we get 28 as our common denominator, that's gonna give us, so 28 common denominator, the first value is going to be 28 minus this is going to multiply by, if it's 28, this is 4, right? 7 times 4, so 7 times 3 is going to be 21. And then this is going to be 12, 28 means 14, so 14 times 1 is going to be minus 14. And then this is going to be just 4, 4 times 3 is going to be 12. So let's add them together and see what we get. It's look like, yeah, so this is 30, 40, 40 minus 21 is 19, 19 minus 14 is going to be just 5. So the final answer is going to be, also we can simplify this one, so 5 on the top, so this is cancel with this one, that's going to give us 40. So 5 over 14 is the final answer. So the volume of this shaded region is going to be 5 over 40, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.